1 and 2. And I'll call this function f. And then I call f with 0. Then what I end up with is a typing judgment that says this whole thing, this whole piece of code is valid, it produces number, but it requires this 2. It doesn't require 1, because 1 I already provided here. And then I can give some value, so it's adding 10 to whatever I put here. It actually runs it and updates it live. I could also say let 2 equal 1 in this. And now it doesn't need anything because all the parameter values are provided. But the really interesting thing here is that it doesn't matter where they come from. They could be available when I declare the function or when I run the function. And this is sort of a toy example, but one nice practical application for this is if you had a distributed programming environment where you can create functions on the server, send them around, send them to the client, then you can actually say, if I have a function that requires current time and let's say time and time zone, then you could create the function on the server and use the time that was available on the server, send it to the web browser, and that would be just a function that requires the other part, the time zone, and so you could sort of get this time that comes from the server, but display it in a time zone that's relative to the browser. So it can sort of capture this idea that the resources you're using in your code can come from different environments. Yeah?
I'm just trying to see to what extent optional parameters or this is syntactic sugar for a form of optional parameters.
So maybe my question mark isn't quite a good name because they're
so you could add all those on the function definition, right? With as optional.
Yeah. Well,
and then of course it depends. So when you call the function, it depends whether. So you'd have to do a lot more typing, surely, to sort of implement that using option.
Yeah. So the way you would sort of implement it is that there's this hidden dictionary with values for all the parameters that you're passing around, and the interesting bit is what happens when you're in a function, because that can access the dictionary that's available in the scope where it's defined, but also a hidden dictionary that comes attached to the input. So in a function you sort of get these two hidden dictionaries, and in this case in one dictionary we have this question mark 1 parameter, in another dictionary we have the question 2.
And the point is that those two dictionaries need not be located at the same stage of the compiling.
They
can be one at compile
and even at runtime, presumably, or not.
No, they're passed around at runtime, but they sort of come from two different places. So one comes from the place where we define the function, and then we pass the function around and call it from somewhere else, and that's where the second one comes in. And then the function has to do something to actually merge these two and propagate it to its body.
And so just sort of going to what Nick Coase was saying, is that if you just had functions with parameters and things, could you translate that into this or that kind of thing formally, or?
So the question is, could I translate something else into this?
or even the other way around. I mean,
So the other way around, I actually do.
Okay.
So I'll go back to it in a second.
Okay.
I think. Nah, I don't have. I have the translation for something else. But yes, so the idea of how this is implemented, and if I go back here, the way this runs when I click check and then enter my numbers, is that actually, so the implicit parameters are one example of some more general system, more general scheme. And I'll show another example in a second. But the nice thing is that the coeffects sort of capture a uniform structure, and they give you the typing rules for it, and they also give you this translation that turns this into an ordinary programming language without special context, without special sort of context syntax. And the only special thing in the translation is that I'm using some additional operations that you have to provide for your specific language. And then you just have to provide like 3 different operations that define how do I look up for a thing in the context. And so I produce this translated code which then uses like 5 library functions that you have to give me, and then I can run it. I think if I take this one, it will look really ugly because it's a yeah. Mm-hmm. But yeah, if I paste it here, it produces something really nasty. The only thing you can actually see here is this merge, where that's the bit where I'm defining the function, and I have this x, which is the context that gets passed when I call the function, and then I have this context 4, which is the one that's been defined where the function is available. And one of the things you have to give me is this merge operation. Yeah.
So this is a little bit like adding a little bit of dynamic scoping, right? In a non-dynamically scoped
language.
Yes.
The implicit parameters are sort of things that support both static and dynamic scoping, and the static is always preferred when it's available in the implementation, and the dynamic is checked by adding these annotations around. So I'll use the last 1 minute just to show you quickly another example.
It'll take 2 minutes.
2 minutes.
Actually, you started late. You can take 5 minutes.
I'll take all your 5 minutes.
Yeah.
So the other one, that's also the other property that can be captured by coeffects, is in this. I'll go to the example. So where's my example? I made it too big. I think that's the problem.
More pages.
So you have a language where you can say pref n, and the idea is it's a data flow language where every variable or every variable, rather than representing just a single value, represents a stream of values. So if I say n plus pref n divided by 2, I'm actually writing a function that sort of you can apply over a stream of values, and it will average the last 2 values. And when I check it, you can see that the type here is now telling me how many previous values it needs. So the number here says how many past values am I looking at. If I add one more pref, then the 1 should change to 2. And it did. So previously my annotations were these sets of parameters that I need. Now it's just numbers representing how far in the history I need to go. And then again, when this evaluates the function, I'll actually build a little user interface here where I can set the current value, so let's go for 1000, the previous value, So I'm looking at pref of pref, so this one doesn't matter. But then this one matters again. So this code looks at the current one and the one before the previous one, because we have two nested prefs there. And what the coeffects system is doing here is that it gives me this type system that can actually infer how far in the history I need to go. And the nice sort of practical application here is that you can actually produce some fixed size buffer when you compile it and make it run faster. And it also gives you this sort of translation that you can use to run it. And I'll end with this shiny example. Because here, what you can do is that you can write a function that takes x and y, and then you can fiddle with mouse around here. And this one was just adding x and y, so it's not doing anything very interesting. But if I load a nicer example, so now I changed it so that I look at pref of v, and then I actually nest this 3 times. So I'm looking something like 12 values in the history, and it was of x. So if I move my x, you can see that, alright, yeah, the red one is following the green one, but is delayed by some bit. So this is one example where what the implementation is doing is that it just allocates a fixed size buffer of things, of numbers, fills it with the values from here, and calculates, runs the function on this fixed size buffer, which just happens to get to the oldest value in the buffer. Or you can do things like smoothing. So this is adding last 12 values and then dividing it by 12. And if I move the mouse fast, so the orange one is sort of smooth version of the green one. Right. So in the data flow, you have this pref keyword where we're just saying if you need r past values and you wrap this in pref, you need +1. And in the lambda abstraction, where when you have somebody that needs r past values, it means that you need r past values of the input and also r past values of everything that's in your current context. Because here you're not really looking at what variables exactly you're accessing.
So in the lambda, that means that the parameters that is attached to the antecedent moves with it when you move it from the context into the body of the function. So in the conclusion, you are moving the term of type tau 1, and you're moving with it also the parameters that it requires.
Yes. So, because the function body can access anything from this whole context, and it can access r past values of anything in this context, it means that we actually need r past values of all the variables here, but also we need to capture it so that when you call the function, you give it enough values. Right, and so the one bit I didn't talk about is that this is kind of rough over approximation because we are not tracking which exactly variables you're accessing, and we do have a variation on the system that does this as well. So there's like a structural version where we keep one annotation for every variable, and then you can say I actually need 5 past values of x, but only the current value of y. And that's the structural version. So I can send you a link to this thing as well. which is a paper that captures these two systems. And so what's the sort of interesting bits here is that there's this nice type system that can capture both the implicit parameters where you're tracking some sets and things like data flow where we just keep one number saying how far we need to go. So it's sort of parameterized over some algebra where you just provide the operations and then you get the type system. The other bit is that it has this translation where you write some program in a context-aware language, and we can translate it into some other language where all the special things are erased and replaced with just normal functions. And that's it. So I sort of talked about two things really, and I think they're vaguely linked to this idea that we are always looking at the context. So it's looking on the left side of programming, where when we have some program, we can look at we can look at how exactly is it using the context. So that's the coeffect stuff, and we can also integrate other things from the external world into this context. And then I guess there's a lot of potential for actually linking the two together, where you could sort of check how far you're looking in an external data source and so on. So that's the two things. Thanks.
Thanks, Thomas. There were already a few questions, but if anyone has more questions,
I had a suggestion of, when we were at the World Bank, where you have your example of a country, it could be a city, because in South Africa we have lots of cities that change names.
Yeah.
But you might still want to reference that city.
Yeah.
So if it is, whatever, the World Bank country name,
Yeah.
and then you could just have a property that says, is it still valid?
Yeah.
And that could be error checking. That makes it easier then.
Yeah.
Maybe it's an idea.
It depends on what the data source can give you.
Yeah.
So to do that, you would actually need the data source to keep the history. And I think the World Bank doesn't do it. They just drop things all the time. So yeah. But if the data source can give you, I think that's sort of where a lot of interesting things could happen, is if the data source can give you some guarantees. Like if the data source can tell you, this I can guarantee that it will be there for the next 2 years, and then maybe I'll drop it. Then your type checker could actually say, your program is type safe until November 2017. Which sounds really scary, but it's just sort of making the things that you currently don't know more explicit. So.
And also you get quite a lot of software that you purchase it and it's dependent on a version of an API.
Yeah.
Twitter is classic example.
Yeah.
And then 3 months later it just stops working.
Yeah.
And the company says sorry, Twitter's banned them or whatever the case is.
Yeah.
It's an entirely different problem when the data provider is happy to support you, right? He'll guarantee backward compatibility.
Yeah.
Then all of a sudden things are easy, right?
Yeah.
But the world's probably, it has to be a rather special environment for that to happen.
Yeah.
But to me, I'm sort of thinking about it. And it seems you could you wouldn't need any special type checking language for anything. You could do it all with C or machine code, and make the call out and say, what does your data structure look like, and then I could run it all. So I could, for instance, print out a full example of a data type that's dynamically typed at runtime, making the call out in C to say what's the type like, and then dynamically parsing it.
Yeah.
That seems straightforward. Your system seems like it buys you something over that.
Yeah. So the thing you get there is the sort of the thing you get when you're writing the code, which is that you know the types of the things at compile time, and there's all the sort of editor tooling that you can build around it that offers you the options.
But it strikes me that any reasonable IDE could provide that to you.
Yeah.
I could write an Eclipse add-on that would provide the data types dynamically asked from the
Yeah.
World Bank, and then they update, change. But
Yeah.
the question really is dynamic. What happens at runtime? Because things are going to change. That's your code's no longer safe.
Your code is as safe as your data source in a way.
Well, you could always catch exceptions, right?
Yeah.
Yeah, but there really is the question of which things might be an exception. You know, if I do, a.next, is next a possible exception?
Well, there are
So every
clear
function
rules
every
that-
function's a possible exception. So you have to put a catch around everything, and
No,
yikes!
No, I mean,
yeah.
in this example, your dynamic references would possibly throw an exception, but a.next shouldn't, right? Unless a is a dynamic type.
Oh,
I
you
mean,
can
it's-
also.
Sorry, unless
There's
the World Bank starts making it NXT instead of NEXT, and then you're screwed.
There's also
I mean-
a sort of range of types you could provide based on a data source. So at one end, you could provide a type where every access returns something that's optional,
Mhm.
and then you'll never get exceptions. But the code you'll write will have to, every time
Do
you're
an option,
accessing
yeah.
anything, you'll have to wrap it in a handler. And at the other end, there's the code where sort of I always just access the value or throw an exception. And then as user, you'll have a really nice API for accessing things, but it can fail all the time. And you could even, that's the nice thing with the type providers is that it's sort of general mechanism where you can plug in lots of different things. And you could write a type provider that takes a number from 0 to 100, where if you give it 0, it will generate these types that are fully safe. If you give it 100, it will generate types that are fully unsafe. And that's something that nobody has really sort of formally played with, but it's probably quite interesting option. Or with the World Bank, you could give one that's you could actually filter the indicators based on how sparse they are. So the World Bank has a lot of sparse data, and when you're programming against it, it's kind of painful because you try to access something and then it has no values. So again, you could sort of fiddle with something to say how sparse data do I want to actually see.
Thanks very much.
All right.
Cheers.